Here we're going to go ahead and work through these problems all together. So there's quite a list here. Let's go ahead and work through 3a first. It asks us to evaluate each of these functions at the x value of 1. So if you remember our notation, this is really important. The notation is that whatever I see inside the parentheses over here is what goes in for the variable on the other side. So f of 1 is 1 squared plus 3, which is 4. G of 1 is in the square root of 1 minus 5. And so G of 1 is not defined. Okay, there is no real number that's equal to the square root of negative 4. If you want to write this as 4i in the complex plane, the complex set of real numbers, that's fine. You can. But if we're talking about just the real numbers, not defined. And then k of 1 is equal to 1 over 1 minus 2, which is 1 over negative 1, which is negative 1. So our three answers to start with are 4, not defined, and negative 1. Okay, let's look at part B. So this is A. So B says to graph each of the functions. Okay, well, this first guy is a squared function up 3 units. So it looks something like that. Okay, that's f. Okay, the next function is the square root function moved to the right by 5 units. Okay, so that gives me, this is g, but this is g of x on this axis, x on this axis. And then our last one is x over x minus 2. This has a vertical asymptote at positive 2. It has a horizontal asymptote at 1. If we plug in 0, okay, we get 0 out, which means that it's got to go through the point 0, 0. So it's going to look something like this. And then, of course, it has no other x-intercepts, so it must look like this up top. So this, of course, is our k of x. Okay. Let me scroll down a little bit. So C asks me to evaluate f at x plus h, g of x plus h, and k. Okay, so f at x plus h. That's x plus h squared plus 3, which is x squared plus 2xh plus h squared plus 3. G at x plus h is the square root of x plus h minus 5, and there's really not a whole lot that we can do with that guy. And then k at x plus h is x plus h over x plus h minus 2. And the last one asks us to determine the difference quotient for each of these. So we need f at x plus h minus f of x over h. So here's f of x plus h. Then we have to subtract off f of x and divide by h. The x squareds cancel, the 3's cancel. And I'm left with 2xh plus h squared over h. And that is exactly equal to 2x plus h as long as h is not 0. If h is 0, this whole thing is going to break down, right? Because we can't divide by 0. So these two guys are equivalent at all spots wherever h is not 0. So this graph right here, this graph right here would be the same. Okay, let's split this a little bit here. Let's do the difference quotient for g. So g of x plus h minus g of x all over h. So that'll be the square root of x plus h minus 5 minus the square root of x minus 5 all over h. Now, the trick here, you could stop here if you needed to, but the trick that you're going to be doing in the next couple sections is to multiply top and bottom by the following. Oops, not over h. Okay, so here's what that gives us. It gives us on the top x plus h minus 5 minus x plus 5. And the bottom it gives us h times the square root of x plus h minus 5 plus the square root of x minus 5. And so on the top, all it's left with, or all that we're left with, is just h. And so these guys cancel out here, and so your final answer is 1 over the square root of x plus h minus 5 plus the square root of x minus 5. Okay, so the last one is k, the difference quotient for k. So that'll be k at x plus h minus k of x all over h. And so we've got to go ahead and compute that. So let's evaluate this. Well, k at x plus h is x plus h over x plus h minus 2. Let me just go back up and make sure that, yep. So then we have to subtract off x over x minus 2. That whole thing is divided by h. So up top here, let's go ahead and get a common denominator. So I'm going to multiply top and bottom of this by x minus 2, and top and bottom of this by x plus h minus 2. So that's going to give me x plus h times x minus 2 minus x times x plus h minus 2 all over x minus 2 times x plus h minus 2 all over h. Okay. Now here we really can't do any factoring here, so what I'm going to do is I'm going to just multiply everything out. So this is going to give me x squared plus xh minus 2x minus 2h. And over here it'll be minus x squared minus xh plus 2x. Now that's over this still, and you would think that it would probably be a good idea to multiply these together, but I'm going to leave them separate right now because it might help us. And now when we divide by h, it's like multiplying by 1 over h. Okay, so I'm just going to be able to put this guy on the bottom. Now what cancels out? My x squareds cancel out. I just lost an h there too. Okay, so my x squareds cancel out, my xh cancels out, my 2x's cancel out, and all I'm left with is negative 2h on the top. And on the denominator, all I've got is x minus 2 times x plus h minus 2 times h. And the h's now can cancel out. And so I've got negative 2 over x minus 2 times x plus h minus 2. Okay, and we'll go ahead and we'll leave it at that.